is Patterson here. Today we're going to go over states of matter. This is part of our physical science unit. So let's talk about the law of conservation of matter. This states that matter cannot be created or destroyed. It can only change forms. So there was a scientist that came up with this idea that no matter what you have, even if it looks like it's gone away, the matter's still there somewhere. It's just in a small amount. So he did a very simple experiment. He took wood and he put it into a sealed box. And inside this sealed box was a little bit of oxygen, okay, the air around it, and he had an ignition switch. And he set this on fire. When he set it on fire, it went from this into like ash, and he was able to capture the smoke. And all of this that was this starting out had changed forms. The fire had broken the bonds that made the wood, that made the oxygen, made carbon dioxide. All of these molecules, these atoms, are still there, but they got rearranged due to the change, and the heat had gone in and changed these bonds. So he took the weight, the mass of this box, he took the mass of this box, and lo and behold, they were both the same exact mass. So this proved that the matter that was all here is here in this box. It just looks different. So that was all the same mass. And you can do a simple experiment like this at home. If you have any Alka-Seltzer tablets or the ones that kind of fizz and you have some water, you can put them together. And when you put them together, you need to put them inside a Ziploc baggie. And then you take the mass of these two separate, take the mass of the tablets and the water, and then you take the mass of all the stuff in the bag, okay, because we got to make sure we capture the gas, then it should be the exact same mass. If the bag is open, the mass is going to be less because the gas that was produced from this reaction is going to evaporate or go into the air, and it's going to leave the bag. So the bag has to be sealed, so it needs to be big enough that it's not going to pop. But if you do that, you can show that same experiment. You'll see that they both have the same mass. So matter cannot be created or destroyed. It can only change form. So a perfect example would be if I give you a piece of chocolate and I tell you, I want you to hold that chocolate in your hand for about 30 minutes. When you open up your hand after that 30 minutes, you're going to have melted chocolate. You would never expect to have a Skittle in your hand. The molecules here are not going to be able to rearrange themselves. Matter has to come in to make a Skittle. And those atoms are not there. So it's going to be the same thing. It's just going to look different. It's going to look like the melted chocolate. So there's 4 states of matter. We have a solid. All the atoms are real close together in a grid. They're real tight. I have a liquid. They're close, but they're able to move. They're able to roll. We have gas, which are real spread out. They don't really come together in any type of bond or attraction. And we have plasma, which is charged. I have negatively charged particles and I have positively charged particles here. And I can do what's called a phase change. I can go from one phase to another. The atoms are still the same, the molecules still the same, and the state has changed. So perfect example is water. If I have solid water, I have ice. If I have liquid water, I have liquid water. If I have water in a gas form, it's steam. So there's still water molecules. And I can jump from solid to liquid, liquid to gas, gas back to... I can move back and forth, and no matter which way I go, it's still going to be water. I take ice, I melt it, I refreeze it, it's still water. It doesn't change. So these are phase changes where I'm able to jump from one state of matter to another. So if I put energy into the system, then that means I'm going to move up these steps. Okay, so if I have a solid and I turn it into a liquid, so just think of ice. If I have an ice cube and I put it in my hand and I hold it and it turns into a liquid, what do we call that? That's going to be melting. If I go from a liquid to a gas, so I have liquid in a pot and I turn on the stove and I let it heat up and it's going to go from liquid to a gas, we call that evaporation. I go from a gas to a plasma. A plasma is kind of weird. It's like lightning. We don't have much plasma here on our planet, but plasma is a lot of our universe, and it's mostly in stars, stuff like that. So if I'm going from a gas to a plasma, we call that ionization. So if I'm going up, energy has to go into it. So I increase energy, I increase it more, I increase it more, I can get to a plasma state. Now if I take energy out, I'm going down these steps. So I go from a plasma to a gas, we call that deionization. I go from a gas to a liquid, we call that condensation. And I go from a liquid to a solid, we call that freezing. And again, these first three, if you think of water, it makes sense. I have gas, it turns into a liquid, condensation. So you think of cans during the summertime, they're really cold, you put them outside, they start to get water on it. So it's taking the warm water molecules that are here, cooling them down, taking energy out, and it's putting them back into a liquid. Once the liquid inside warms up to the temperature, it's going to start to heat up, and then as it heats up, the water molecules are going to start moving faster, and then they're going to evaporate back into a gas. So that's why water droplets don't stay on your Coke can for very long during the summertime. Same thing here, if I go from a liquid to a solid, I go from here, I'm going to freeze, I go from water to ice, it freezes. I can also jump a phase. This takes a lot more energy to do that. So I can actually jump from a solid to a gas. I can skip this liquid phase. We call that sublimation. And we see that with dry ice. I have frozen carbon dioxide. I can put this in water and it bypasses the liquid state. It automatically starts to boil. So now I'm going to have this dry ice effect where I have like smoke that comes out. We also have it with a gas to a solid. I skip this liquid phase. The gas goes directly to a solid. We call this deposition. You see this during the winter time when you have these ice crystals that form on your car. So you'll be out in your car first thing in the morning. It's really cold. The temperature drops fast enough that when water gas molecules hit your car, these water molecules are going to stick and then they automatically start to turn into ice. And so they solidify when they hit. So you get these really pretty crystalline structures, these little feathering that happen on there. So that's deposition. You'll see that in the wintertime. And we have what's called latent heat. Latent heat or latent phase change. This is saying that I'm going to have ice. I can have a solid piece of water. And then at 0 degrees Celsius or 32 degrees Fahrenheit, I can go from ice to water, or I can go from water to ice. This is going to be the point where water can freeze or melt. It just depends which way I'm going. If I'm really wanting a snow day, I'm wanting 32 and I'm wanting it to drop. If I'm tired of the snow and the ice, I want 32, but I want it to go up. So this is the point where ice is no longer going to be able to stay together, and this temperature here is going to stay constant until it goes into a liquid form. So this here is the point, and you got this up here too, this is the point where the energy being used is going to transfer it from one state, a liquid, to a gas, or from a solid to a liquid. So up here I have water and steam. If I put a pot on a stove and I set it to boil, and I put a thermometer in it, it would never get above, as long as it's pure water, it would never get above 100 degrees Celsius or 212 degrees Fahrenheit. That energy is going to be used to take that liquid water and turn it into steam. Now, if I let that pot boil and I forget about it, I come back, all the water's gone, because all that energy used to heat up the water has been used to break those bonds in order for the water, the hydrogen bonds that hold the water together, to break off, and now I have steam. So this is the point where you're going from one state to another. So this is my latent phase change. My latent heat line is this. So this is just showing I'm going from one state to another, and then I need this energy. This energy is going to stay constant. My temperature is going to stay constant, and that's because I need to go from one state to the next. So melting and freezing, this would be the same line. And then up here, boiling, condensing, this can be the same. I have to use the same amount of heat energy to put them all back together, same amount of heat energy to break them apart. So this part here is the energy that's needed. All right, that's going to be states of matter. It's a pretty easy one. If you guys have any questions, let me know. Talk to you later.